So this question, it tells us that we're designing this kite on a set of coordinate axes. We're told that each unit represents 10 centimeters, and we're told the coordinates of A, B, and C. So we need to find the gradient of the line from A to C. So the gradient between A and C, we need to know the coordinates, and then we're going to use the gradient formula, which is the change in Y over change in X. So the coordinates of A, if we write this down, I'm actually just going to label all of the coordinates onto my diagram. So we have 2, 0, and then B is 0, 4, and C is 4, 6. So if we're trying to find the gradient between A and C, then we're going to use the gradient formula, which is the change in Y values over the change in X values. So for the coordinates that we're working with there, we have 6 minus 0, all divided by, and then it's 4 minus 2. So we can see there that the gradient is 6 divided by 2, which is therefore 3. So the gradient of my line is 3. And then for part B, it says to write down the gradient of the line from B to D. So we can see on our diagram here that B and D is a right angle. So we're asked to find the perpendicular gradient. So to find a perpendicular gradient, then the m, or the gradient of the perpendicular, is equal to -1 divided by the previous answer. So it's going to be -1/3. And that's the gradient of BD. Okay, is -1/3. The value we found here was the gradient of AC. Okay. And then for part C, it asks us to find the equation of the line from B to D. So the equation of the line that kind of cuts through the middle of our kite here, this one here. So for the equation of the line, we know that we can use the point slope formula, which is this one here. And we need to know one of the coordinate points, which we have B, so that's 0, 4. And we need to know the gradient of that line, which we know is -1/3. So we're going to substitute all of that in. So we have y minus, and then the y coordinate is 4, and that's equal to -1/3, the gradient, x minus 0, which is the x coordinate. And then we need to rewrite that in the format that it's asked for here, which means that we need to rearrange it all and make it equal to 0, and A, B, and D are integers. Now, integer just means that it has to be a whole number. So we're going to rearrange this. We've got y minus 4 is equal to -1/3 x. So we're multiplying this out, minus, and then this is just 0. And then we're going to rearrange that to put it all on one side. So y plus 1/3 of x minus 4 is equal to 0. Now we don't want any fractions there. We wanted it to be an integer, so we need to get rid of that fraction. And the way that we're going to do that is by multiplying everything by 3. So we're now going to have 3y plus x minus 12 is equal to 0. And then the last part there is part D. And in part D, we're asked to find what is the coordinate point of D. So we know that the y coordinate of D is 0, but we're trying to find what is the x coordinate. So we know that that line goes through it, so we can use the equation of the line we've just found. So in here we have 3 lots of 0. So I'm literally just using the equation I've just found, plus x, which is what I'm trying to find, minus 12 equals to 0. And you can type that straight into your numeric solve and find that x is equal to 12. Okay, in which case x is equal to 12, and you found the x coordinate. So it's 12, 0 for coordinate D. So in terms of the marks for this question, the first part is worth 2 marks. One is for using the method of the gradient formula correctly, and the other is for the answer. For part B, there is 1 mark, and that's just for finding the answer there, so that's just 1 answer mark. For part C, it's again 2 marks. 1 of the marks is given for correctly substituting into the point slope formula, and then the second mark is if you then manage to rearrange it into the correct form at the end. And then for part D, it's just 1 mark, and that is for finding the 12. Okay, and you can either write it as an equation, x equals 12, or, as a value stating it, or you can write it as the full coordinate point.